All right, in this problem we have a kite, and the kite has diagonals that are 6, so it's 6 units wide, and 15, so it's 15 units tall in the sense the way I've drawn it. And the question is it possible that this kite has side lengths that are in a 2-to-1 ratio, or the long sides are twice as long as the short sides? And so keep in mind that the way I've drawn this, I drew it, with the one diagonal crossing up here at the top of the cross, but I could have brought this down here further, or maybe all the way down here. I suppose if I bring it too far down, then I've just sort of flipped it upside down. But I could place this diagonal all sorts of different places. And the question is there a place I could put it? Could I have drawn it down here, or down here, or down here, so that the side lengths end up being in that 2-to-1 ratio, meaning that the long sides are twice as long as the short sides? And the answer is yes. Now, if you're trying to prove that something could happen, all right, then I guess one way of doing it is to simply find it, right? If such a kite exists, a kite that has diagonals of 6 and 15, and the side lengths are in a 2-to-1 ratio, then it must, I'll just find it. So let's find it. So what we're looking for is, I put some labels in here. This diagonal here, we're just going to call this distance up here above the diagonal x. Right? We're going to find some unknown like x, and below it would be 15 minus x. Right? And so we're going to do a couple little Pythagorean theorem or distance formula type problems here. We're going to find this length, and we're going to find this length, and we're going to find an x value where this length here and this length here, one's twice as long as the other. So let's take a look. So the short length, that's easy, right? This is just x squared plus 3 squared equals c squared, right? So I would say x squared plus 3 squared equals c squared, but I want like a formula sort of thing, so I'm going to put it in square root of. So this little formula right here will give me this length here. I plug in different values of x and I can find those. And then on the other hand, I've got 15 minus x squared and 3 squared, so 15 minus x squared plus 3 squared equals c squared. That would be for the long side, but I'll put in the square root bracket part here. So now, if I fill out this little formula here, then I would be calculating the length of this side here for different values of x up here. So as I make this longer, 15 minus x gets shorter, and so I suppose this length also gets a little bit shorter. So we're looking for when does it take 2 of these to equal one of those. So 2 of the short lengths to equal one of the long ones. So let's solve this equation, 4x. Well, first thing I'm going to do is get rid of these square root brackets. I'm going to square both sides. Right? So over here I just end up with 15 minus x squared plus 3 squared. That's just 9. Over here on the other side, when we square, be careful. We get x squared plus, and that's just 9 again. But over here, 2 squared, we got to square the 2 as well, so we end up with a 4. Okay. So then, let's see, I'll distribute this 4. And I get 4x squared plus 36. And oh, I forgot to hold on a second here. That's not. Okay. Let's put my parentheses in over here. And then I've got on this side, we have 15 minus x squared plus 9. Now we're going to have to open this up over here. This is going to get kind of ugly, but before we do, let's move this 9. Let's get rid of this 9 over here before we open it up. Right, so I'm going to subtract 9 from each side. So that's going to be 4x squared plus 27 equals 15 minus x squared. No, I just do that because I want this to be by itself before we open it up. Now, when you open up a perfect square binomial here, open up this. So I've got 4. I'm just going to leave this side alone for now. The trick here is, so it's going to be 15 times, so we're going to multiply, we're going to FOIL it out in a sense. In fact, here, let's write that out. 15 minus x, 15 minus x. So that's what 15 minus x squared means. We're just going to multiply this binomial by itself. of 4x squared plus 27. So I'm not changing anything over here. Over here, I have 15 times 15, that's 225. And then I've got negative x times negative x. And so that's going to be positive x squared. And then I'm going to have a 15 times negative x minus 15x. And then I'm going to have another 15, but this time times negative x, so another negative 15x. So see, when you multiply this out, I get the one number squared, 225. I get the x squared, and then I get the two parts multiplied by each other, x times 15, but I get two of those. So I end up with, see, I've got 4x squared plus 27. Nothing changing over here. Then I have 225 minus 30x plus x squared. So you'll notice, again, you end up with the one part squared, the other part squared, and in the middle, double the two multiplied together. And that's important for later on. Remember that little star here. All right. How this turned out. Okay. Remember how that turned out. Because we're going to have to work that process in reverse later on. Okay, so let's see. Do some combining of like terms. I'm going to take 4x from each side. Equals 225 minus 30x minus 3x squared. So I'm taking 4x squared from each side. Now let's see. What I want to do is I want to actually bring this. I want to take this 225 over here. All right. So I'm going to subtract 225 from each side. So 27 minus 225 is 198, negative 198. So I have negative 198 equals negative 30x minus 3x squared. Now, I want this coefficient here to be a 1, so I'm going to divide everything by 3. And this works out nicely because all these numbers are divisible by 3. Actually, I'm going to divide by a negative 3, by the way. So let's see, 198 divided by 3 is 66. So I'm going to end up with a 66. I'm going to leave it as negative, actually. We're just going to divide by 3. Negative 10x minus x squared, so divide everything by 3. Now I'm going to multiply everything by a negative 1, giving us 66 equals 10x plus x squared. And then I'm just going to do a little rearranging over here. 66 equals x squared plus 10x. Okay. So now remember I said we had to reverse that process from earlier. What I want to do is I want to put this back into this form right here. Right? And this is a process of solving this equation. It's called completing the square. I'll show you how it works. So it's a kind of an odd way of solving for x. Let's see if you can reproduce this method on your own. What I want to do is I want to add x squared plus 10x. Half of 10 is 5, and 5 squared is 25. So you'll see, when we went up here, we had x squared, and then we had the 225, and then we had, which was the square of 15, and then we had two 15x's put together. So what we're trying to create down here is, we have the x squared, we have 5 squared, and we have two 5x's put together. So this is going to become x plus 5 squared. Over the other side, of course, I added 25 over here, so I have to add 25 over here. Seeing 25 and 66, we have 91. 91. Okay. Now, I take the square root of both sides, keeping in mind that it's going to be that plus or minus thing, we've talked about this before, equals x plus 5, and then I'm going to subtract 5 from each side, and I end up with negative 5 plus or minus square root of 91 equals x. And this value here, let's find out what that is, roughly anyway. So we've got negative 5 plus second square root 91 gives us 4 point, let's say 5394. So we got 4.5394 approximately. And negative 5 minus second square root 91 gives us 14.5394 negative, or negative 14.5394. Now, the negative value, that's not going to make much sense in terms of our original problem. Let's go back and look at it again. Our original problem was how long does x need to be so that this side here is half as long as this side here. A negative value for x just doesn't make any sense. So it must be that this positive value is it right here. So 4.5394 approximately. So approximately 4.5394. So if x is about that long, specifically that number is negative 5 plus the square root of 91. But let's see if it kind of pans out. Okay. So let's see. How long will this side be? So let's see. I'm going to go down here, and I'm going to say 3 squared plus 4.5394 squared equals c squared. So we're going to find this length up here. So let's see. We'll go. Well, we got the number. No, it's not the number we want. So 3 squared plus 4.5394 squared, right? And we'll take the square root of that. Second answer, 5.4412. 5.4412. 5.4412 equals C. Okay, I'll label that up here. 5.4412, approximately equal to. Now let's find the other one. So let's see, if this is x, then 15 minus x must be 15 minus, 4.5394. This is 10.4606. So this distance here would be 10.4606. Again, that's approximately equal to. So, do our Pythagorean theorem calculation to find the long side. So I've got 3 squared plus 10.4606 squared equals c squared. So let's see. 3 squared plus 10.4606 squared equals, right, and we'll take the square root of that. And we get 10.8823. 10.8823 equals C. Right, and that's this side over here. 10.8823. And so half of that divided by 2 is 5.4411. Well, approximately twice as big as that. So again, to set up our equation, right, we did use like a little Pythagorean theorem calculation for the short side, Pythagorean theorem calculation for the long side. So 2 of these equals 1 of those. We had to solve. Right. The tricky part's here, expanding this binomial. And then the other tricky part was doing this, completing the square bit. So we want to whittle it down to where we have the x squared plus whatever x, and then we want to add on half of whatever this coefficient is and then square it. So we can do this. So pay attention, special attention to this bit right here. Okay. And I push down a little bit. So see if you can reproduce that with your own, and then when you get your answer at the end, go back and check it.